इस क्वेश्चन में हम बोल रहे कि एक्सरे ट्यूब के अक्रॉस में यानी एडजेस में 20 किलोवाट्स ऑफ पोटेंशियल डिफरेंस अप्लाई किया गया है। अब हमें कैलकुलेट करने के लिए पूछ रहे मिनिमम वेवलेंथ कितना है उसका। सो हमें पता है E इज इक्वल्स टू एच सी बाई लैम्डा, E इज इक्वल्स टू एच सी बाई लैम्डा और पोटेंशियल एनर्जी इज इक्वल्स टू एच सी बाई लैम्डा। यानी इधर एनर्जी दिया था 20 किलोवाट्स दिया था, ये किलोवाट्स में, तो इसको वाट्स में कन्वर्ट करेगा तो ये क्या हो जाएगा 20,000 वाट्स हो जाएगा। हमें कैलकुलेट करने के लिए पूछ रहे इधर लैम्डा का वैल्यू कितना है। इधर ये लैम्डा का वैल्यू हमें फाइंड आउट करने के लिए पूछ रहे क्योंकि लैम्डा है वेवलेंथ, देयरफॉर लैम्डा क्या हो जाएगा यानी वेवलेंथ क्या हो जाएगा एच सी बाई ई हो जाएगा। हमें पता है h इंटू सी का वैल्यू है 1240 एंड ई का वैल्यू है 20,000 वोल्ट्स है, 20,000 वोल्ट्स है। सो इसको कैलकुलेट करेगा तो हमें वेवलेंथ का वैल्यू निकलेगा 62 इंटू 10 टू द पावर ऑफ -3 नैनोमीटर से और लैम्डा इज इक्वल्स टू 0.62 एंगस्ट्रॉन्स। therefore हमारा आंसर है 0.62 एंगस्ट्रॉन्स।
Hello everyone, welcome to this video. So in this video we are going to solve this question. In an X-ray tube, electron accelerated through a potential difference of 50,000 volts strike a copper target. The speed of the emitted X-ray inside the tube is, see friend, as we know that X-ray are an electromagnetic wave and the speed of electromagnetic wave is equal to the speed of light, that means c. Get it? Therefore the speed of emitted X-ray is also a c or 3 into 10 power 8 meter per second. Get it? Because speed of X-ray is not depend on potential or potential difference applied. Get it? Therefore speed of X-ray will be 3 into 10 power 8 meter per second. Get it, friend? Thank you for watching.
Hello everyone, let us start with our question. In this question, what is given? Wavelength of the characteristic X-ray K alpha line emitted by hydrogen-like element is given as to be 0.32 lambda. Okay, basically it would be 0.32 angstrom, not lambda. Now the wavelength K beta line emitted by the same element will be. Okay, so we need to find what is the wavelength of K beta this line in angstrom. Okay, now we know that 1 by lambda we know that it would be equals to z square r. For any material it would be n1 square minus 1 divided by n2 square. Okay, or we can say that it is constant, so we can just write it as k 1 by n1 square minus 1 by n2 square. It would be like this. Now for our k alpha, okay, for k alpha, so transition would be from 2 to 1. Okay, so we can say that 1 divided by k alpha, we know the value of k alpha is given as to be 0.32 angstrom, equals to be some constant, we just say it is constant k, then 1 divided by this n1 would be equals to 1, so it would be 1 square, that means 1, minus 1 divided by 2 square, that means 4. Okay, so it would turn out to be 3k by 4. Now for our k beta, so our n1 would be equals to basically 1 and n2 would be equals to 3. So we say that 1 by lambda beta, we can just write, would be equals to k times 1 minus 1 divided by 3 square is 9. So this would turn out to be 8k divided by 9. Okay, this is equation 1, this is equation 2. So if we divide these two equations, if we divide 1 divided by 2, 1 divided by 2, this would be what? So if we divide, so 1 is 1 divided by, this would implies that 1 divided by 0.32 divided by 1 by lambda, this is our LHS. And what is the RHS? 3k by 4 divided by 8k by 9. Okay, so this would turn out to be lambda beta, so this is beta, so it would be lambda beta divided by 0.32 would be equals to, so this would turn out to be 9 would be in the numerator, so 9 into 3, that is 27, and 8 into 4 is 32. So that means our lambda beta would turn out to be 27 divided by 32 into 0.32. So it would be just what? So we can just cancel and it would turn out to be a point divided by 100. So it would be just 0.27 angstrom. Okay, so this would be the answer. So we need to find the value for k beta, wavelength for k beta. Okay, so hope you have understood this solution. Thank you.
The given question is, when the number of electrons striking the anode of an X-ray tube is increased, the dash of the emitted X-ray increases. So this is the first part of the question. Let's check this. So it is given that, see, we are having X-ray tube, okay, like this, on which a number of electrons are being, as a beam, are being striking this X-ray tube. Now we have asked that what thing will increase. So here we can say, in this first filling the blank, it will increase the intensity of the X-rays. Okay, see, because we know that the greater the number of electrons striking the anode, larger will be the larger will be the number of X-ray photons emitted. Okay, X-ray photons emitted, which in turn will increase the intensity of the X-rays. Okay, further we also know that, see, intensity can be controlled by the number of electrons striking the target area, okay, per second. So if we increase the more the number of electrons, then intensity will increase. Okay, now in part 2 we have, when the speed of the electrons the anode are increased, the cutoff wavelength of the emitted X-ray. Okay, so now in the part 2 we are increasing the speed of the electrons now. So see, speed is somewhere connected to the kinetic energy, and we know that the kinetic energy is given as hc by lambda. That means kinetic energy is inversely proportional to the wavelength. Okay, so in this case, if speed is increasing, that means kinetic energy is increasing, and if kinetic energy will increase, the wavelength will decrease. So in the second option, it will come decrease. Okay, the cutoff wavelength will decrease if the speed of the electrons are increasing. Thank you.
Hello. So the question is, to produce the X-rays characteristics using a tungsten target X-ray generator, the accelerating should be greater than volt and the energy of the characteristic is in electron volt. So basically here we have to find volt and the energies. Okay, and we have given the binding energy of the innermost electron tungsten is 40 kilo electron volt. Okay, so now using the given information here in this question, first of all let us try to find out the electron the okay, so let us try to find out the energy. Okay, very first, and we know that first of all the relation for the lambda, it can be written as for X-ray. Basically very first, for the X-ray, we know that when we are talking about the transition, so X-ray here the transition follows that n1 equals to 1 and n2 equals to 2. Okay, so let's say here you can write that the 1 upon we know that 1 upon lambda equals to r. Okay, z minus 1 to the z minus 1 to the whole square, and here it can be written as 1 upon n1 square minus 1 upon n2 square. This is the relation for the lambda. Okay, so now from this, and this relation can be written as, we know that the energy can be written as hc upon lambda. So lambda can be written as hc upon E. Okay, so when you talk about for 1 upon lambda, you can write it as E upon hc. Okay, that just inverted of the term. So let us write it E upon hc. Okay, so now let's say for the very first E1 upon hc. Okay, so now use the given information that we have. So here let's say E1 upon hc equals, here this is r and z is basically 2, so 2 minus 1 to the whole square. Here 1 upon n1 is 1, so square of 1 is 1, and here 1 upon 2 square is 4. Okay, so this will be let's say this is equation number 1. Okay, now we know that the binding energy is given to us, binding energy which is given to us in the question, it is 40 kilo electron volt. Okay, and we can find the ionization potential of the tungsten. Okay, so you can write it as 40 into 10 raised to the power 3 also. Okay, you can write this as 40 into 10 raised to the power 3. Understood? Okay, here we find the energy for the first. Similarly, let us try to find for the second also. So E2 also is written as same, E2 upon HCr. Here 2 minus 1, 2 minus 1 to whole square. The only thing that is changed is N1 will remain same 1, but the N2 will be what now? It will be infinite. Okay, so here it will be 1 and here it will be infinite, so that infinite is square, so that all we come to 0. Or when you multiply uh, here this will be 0, so here we have only E2 by HC equals R, and this will be 2 minus 1 of square is 1, 1 square is 1. Okay, here it will only R. This is E2 by HC that we have. So now we have E1 or E2 both. So when you divide E1 by E2, okay, so you will get here the R cancel out with each other. So we have only 1 minus 1 upon 2 square, and let's say when you write this here, this will be 0. Here this will be 0. Okay, sorry, here this will be 1 only. Here this will be 1 only. So 1 minus 1 upon 2 square. So this will be 3 by 4. So you can write that energy for first E1 can be written as 3 by 4 into E2, and E2, that is the energy, binding energy that we have given is 40 kilo electron volt. Okay, so let us put it. So 3 by 4 into 40 into 10 raised to the power 3. This 40 cancel out 10 times. Okay, so we have energy is 30 and 30 electron volt, means 30,000 electron volt. This is the first answer of this question. Now similarly we have to find potential minimum, so that can be find out by simply saying E1 divided by E. Okay, so when you divide, okay, so put the value of E1, which is 30,000, which is in electron volt, to be divided by E. Here E cancel out, so we got the V minimum as, the V minimum is 30,000 volt. Okay, this is your answer. Thank you.